Now I'm going to explain how to solve this given LPP by simplex method. Here the objective function is maximize set, so we don't need to apply the set that dual property in order to convert it to maximization problem. So now here you see that the objective function is maximize set is equal to this one subject to two constraints here, where the first constraint is less equal to 200 and the second constraint is less equal to 200, where all xi are greater equal to 0. So first of all, before we write the initial simplex table, what we need to do now, we have to convert this less or equal sign to equality sign. For that, we need to add the slack variables to the first constraint, and also to the second constraint we need to add the slack variables. So therefore, the given LPP can be expressed as maximize set equal to 80x1 plus 160x2 plus 200x3. Since I add a slack variable x4 to this one and x5 to this one in order to convert it to equality sign, so I can write this one, add this one, 0 into x4 plus 0 into x5. So this one gives you the original objective function only. Now subject to the constraint. So the first constraint now become x1 plus 3x2 plus 5x3 plus 1 into x4 is equal to 200. And for the second constraint, you add x5. So 2x1 plus 2x2 plus 2x3 plus 1 into x5 is called 200. So x4 and x5 are called the slack variables, where all xi are greater equal to 0. So now after converting all the inequality sign in the constraint to equality sign, then you write this initial simplex table will be what? So in the first box, you have to write the coefficient of non-slack variables. The non-slack variables in this case are x1, x2, x3. So what is the coefficient of x1, x2, x3? In the first constraint, it is 1, 3 and 5. So you write it here. The second constraint, it is 2, 2, 2. And here in the last column, you write the negative value of the coefficient of x1, x2, x3 from the objective function. So it is minus 80, minus 160, minus 200. Now in the next box, you have to write the coefficient of slack variables. So coefficient of slack variables is x4 and x5. So in the first constraint, it will be 1, 0. The coefficient of x5 in this first constraint will be 0. So it will be 1, 0. In the second constraint, the coefficient of x4 is 0. So it will be 0, 1. That is the coefficient of x5 is 1. And then this one, 0, 0. You write it down here. And bi here will be the value of the equation on the constraint. So the first one is 200 and the second one is also 200. And here you have to write 0, their initial value. So this is the initial simplex table. So let us solve this one to find out what will be the value of x1, x2, x3 in order to maximize the given objective function. So the first step here, what you need to do now, take any column from this coefficient of non-slack variable. So let us consider this first column. Now by considering the first column, because we have the negative entry here, so we can take either this column or this one. Doesn't matter, because all the entries in the last column, in the last row, are all negative. So but we can select any one of the column where there is a negative entry in the last row. So let us consider this one. So for this one, what you need to do now, divide this bi by this ai, by the value of ai from the first column. So it will be 200 by 1 will be 200. Now you divide next this one, 200 by 2. Then it will become 100. So now on dividing this one, this bi by this 2 here, then it will become 100. That is aij by bi. So now you see that from among these two, this one is the smallest positive quotient. So 100 is the smallest positive quotient. Both are positive, but this is the smallest. So therefore, you round this one and circle this one, and this will be called as the pivot entry. And since it belongs to the first column, where I denote this first column as P1, P2, P3, then you mark here as P1 on the side of this table. Then after that, next step, what you need to do, convert this pivot entry to 1. To do that, since it is in the second row, so R2 now, you divide it by half. So on dividing it by half, then this entries, this table now will become, the first one will remain the same, 1, 0. This will be 200. Now this will reduce to 1. That means throughout you have to divide by half. So this will be 1, 1, then 0, half, and this on dividing by half will become 100. And then next, this minus 80 will be there, minus 160 will be there, minus 200 will remain as it is, 0, 0. So now we have seen that after finding the first pivot, then in that case you reduce that pivot entry to 1, and for that we divide it by half. Now next you convert all the columns that is below and above this pivot entry to 0. That means I have to convert this one to 0 and this also to 0. For that we need to apply this row operation. You apply the row operation for R1, that is this row 1, in order to convert it to 0, then it will be R1 minus R2. And for this one minus 80 to convert it to 0, this belong to the third row. So for this one you apply this, it will be R3 plus 80 times of R2. So apply this row operation. For R1, you apply R1 minus R2. For R3, it will be R3 plus 80 times of R2. Then in this case, you'll see that the new entries now will become what? The first entry now will become 0 here. The second entry will become 2. The third one will become 4. Then 1 minus half after applying this row operation. Then this will become 100 because R1 minus R2. So it will be 200 minus 100. So it will become 100. Then this last one, the second row will remain as it is, 1, 1, 1, 0, half, then 100. And then this one will become 0 because you apply R3 plus 80 of R2. So 80 times of this R2, 80 into 1 will be 80, plus with this one it will become 0. Now 80 of this one plus with this, with minus 160, it will give you minus 80. Then 80 into 1, it will be 80 plus 80 minus 200, then it will become minus 120. And here it will be 0 only because 80 into 0 will be 0, plus with 0 here will become 0. Now 80 into half. 80 into half will give you 40. So 40 plus with this 0 will become 40 here. And this one, the initial value is 0. But now you multiply by 80. 80 into 100, it will become 8,000. 8,000 plus 0, it will become 8,000. So here the new table, simplex table, will be this one. But we still have the negative indicators in the last column. So what we need to do now, we still have to convert all these negative indicators to either 0 or positive number. So what next we do? What we do now is take this column, second column, and then let us see, this is that BI, then take the quotient of that one, BI by AI, BI by AIJ. So you divide this one now, since it belongs to the second column. So you divide this 100 by this and 2 here, then it will become 50. Divide this 100 here by 1, then it will become 100. Now since both are positive and this 50 is a smallest positive integer, therefore from among these two, then in that case you encircle this one. So this will be the pivot entry. So it is P2 since it belongs to the second column. Now this one will remain as P1. Now this will be the pivot entry. So next step, after getting the pivot entry, we convert this pivot entry to 1. So what you need to do now, for the first row you need to divide throughout by 2 in order to make this pivot entry to 1. So this is P2, P1. So here you write for R1, convert it to half of R1. So that the 0 divided by 2 will become 0 only. And this on dividing by 2 will become 1. 4 divided by 2 will become 2. Then 1 divided by 2 will become half. Minus 1 by 2 divided by 2 will become now 1 minus 1 by 4. 100 divided by 2 will become 50. Now this will be 1, 1, 1, 0, half, 100. 0 minus 80 minus 120, 0, 40, 8,000. So now next what we need to do now, we have to, since this is a pivot entry, so we have to convert the entries in that column below the pivot entry to 0. That means I have to convert this one to 0 and minus 80 also to 0. For that I have to apply this row operation. For R2 now you apply the row operation, R2 minus R1. And then for the third row you apply the row operation, R3 it will be R3 minus or R3 plus 80 of R1. So you'll see that after applying this row operation, let us apply first to R2 by this operation. So this 1 minus 0, it will be, okay, let me write that 1, that will remain as it is, half minus 1 by 4, 50. Now the second row will change its value after applying this row operation. So R1 minus 0, it will become 1 only. Now 1 minus 1, it will give you 0. 1 minus 2, it will give you minus 1. 0 minus half, it will be minus half. Now 1 by 2, minus of minus 1 by 4. So it will become 1 by 2 minus into minus will become plus 1 by 4. So this will become 3 by 4. So here it will be 3 by 4. Now this one minus this, 100 minus 50, it will be 50 by applying this row operation. Now next, for the third row, you apply this row operation. To R3, it will be R3 plus 80 of R1. So 0 plus 0, it will be 80 of 0, it will be 0 only. And then the next one will be what? It will be minus 80 plus 80 times of R1. So that one, 80 minus 80 will become 0. Now 80 or minus 120 plus 80 times of into 2. 2 into 80 will be 160. 160 with minus 120 will give you 40 plus 40. And this one, it will be 0 plus 80 divided by 2. It will become 40 here. 40 plus with this 0, you will get it as 40. And then next, this one, you multiply this minus 1 by 4 because 80 of R1. So it will be minus 80 by 4 will become minus 20. Minus 20 plus with this value in R3, that is 40, you will get it as 20. Now multiply this 50 with 80. 50 on multiplying with 80 will give you 4,000. Now 4,000 plus with already this 8,000 here, then in that case it will give you 12,000. Now what we notice is that in this table, we see that there are no more negative indicators in the last row. Therefore, this will be the final simplex table. So now here, this is P2 and this is P1. So therefore, the maximum value of the given objective function of the given LPP will be maximize set is equal to 12,000. So this is the maximum value. So this will be the value of the given LPP. And then what will be the value of X? Because in that one, we have the value of X1, X2, X3. So now what will be the value of X1, X2, X3 from this from this final simplex table? Now what we notice is that P2 represent this first row and P1 represent the second, but this value in the last column will give you the value of those X1, X2 and X3. Now since P2 is there, so this will be P2, and it occur at this one X1, X2, X3 equal to that one P1, P2, P3. Okay. The value of X1, X2, X3 will be same as that P1, P2, P3. But in this case, we see that what is the value of P1? P1 in the last column is equal to 50. So the value of X1 will be 50. P2 also we have it as 50. But there is no P3 on this side of the table. So that means P3 is equal to 0. Now, if you want to check that whether these values of X1 is equal to 50, and X2 is equal to 50, X3 is equal to 0, is the value of the objective function which gives you 1200 as a maximum value. Then you can cross check it here by putting X1 is equal to 50. So if you put X1 is equal to 50 here, so 80 into 50 will become 4,000 plus 160 into 50, that is X2 is equal to 50. So this one will give you 8,000. Plus this one 200 into X3, that is 0, so it will be 0. So 8,000 plus 400, it gives you 12,000. So which is exactly the value given in that final simplex table. So on this side will give the value on this side will give you the value of X1, X2, X3 depending on where we have marked this one pivot entry. If in the first row, is marked as P2, that means this will be the value of X2. if the second row is marked as P1, then this will be the then 50 will be the value of that X1. And since there is no marking for P3 on this side, so it means that the value of P3 is equal to 0. Hope it is clear now how to find how to solve the given LPP by simplex method for a maximization problem.